In the age before wrecking balls, crews brought down entire skyscrapers using nothing more than sledgehammers, ropes, and sheer nerve, sometimes dismantling 20 stories brick by brick from the roof down. These demolitions unfolded over months, driven by a thriving salvage market and plagued by collapse risks at every turn. How did they plan, survive, and profit from such dangerous, methodical work with only the most basic tools in hand? The answer begins at the very top. Demolition crews started at the highest point, stripping away the roof before touching anything below. On a typical city block, the first step was to remove roof decking and coverings, exposing the beams and rafters to daylight. Workers pried up slate tiles or tarred paper, then hauled away planks and joists, always careful to avoid sudden shifts in weight. Each layer came off in a set order, roofing first, then the uppermost floorboards, then joists and supports so that nothing below would be left carrying more than it could bear. Openings were cut in the floors early on, creating makeshift shafts that ran from the roof all the way down to the ground. These shafts served a double purpose. They let debris fall straight to the basement or street, and they kept the work area above clear and safe. In some buildings, elevator shafts were converted into chutes, lined with boards to prevent bricks and timber from jamming as they dropped. Workers stationed at each level swept debris into these openings, sending a steady stream of rubble down to waiting carts or piles below. This top-down sequence wasn't just about gravity, it was about control. By removing the weight of the upper floors first, crews reduced the risk of collapse and made it easier to spot weak spots as they worked. Every move was calculated, every beam and brick removed in a way that preserved the structure's balance for as long as possible. The process set a rhythm: strip, clear, check, repeat. The methodical pace allowed crews to work safely, even as the building shrank around them. The pattern was always the same: roof, upper floors, supports, then down another level, until only the lowest beams and foundation remained. By the time the last joist was pried loose, every salvageable piece had been set aside and every hazard managed. The logic of starting at the top and working down shaped every demolition before the wrecking ball era, laying the groundwork for the careful tool work that followed. A demolition worker's hands tell the story of a building's end. Every tool in the kit served a specific purpose, matched to the material and the moment. Sledgehammers came out for masonry, for thick brick walls, stone lintels, and concrete blocks. It was not about swinging wildly. It was about aiming for weak points, striking where the mortar had already begun to give. The weight of the hammer did the work, breaking walls down one controlled blow at a time. Crowbars and pry bars were the tools of patience. Workers wedged them into gaps between floorboards or under iron fixtures, rocking them back and forth until the nails surrendered. When it came time to separate bricks, the crowbar slipped into old mortar seams, popping them free with a twist. For stubborn beams, the leverage of a long bar could coax even the heaviest timber loose, all without splintering what might be worth saving. Pickaxes found their place in the soft spots, plaster, mortar, and the crumbly layers between bricks. With each swing, the pick chipped away at the binding material, loosening the structure piece by piece. It was not brute force, but a practiced rhythm, the sound of metal on stone echoing through empty rooms. Handsaws cut through joists and beams that could not be pried apart. Each saw left a clean edge, making it easier to reuse the timber elsewhere. Workers preferred the crosscut for thick floorboards and the rip saw for beams, always careful to follow the grain. A good saw, kept sharp, could slice through a joist in minutes, leaving behind a stack of salvageable wood and a clear path for the next stage. Every tool left its mark, but it was the worker's judgment that decided how deep to cut, where to pry, and when to hold back. The right tool, used the right way, made the difference between wasted effort and a clean salvage. This was demolition as craft, hands guiding steel, steel shaping wood and stone. and every action aimed at taking the building apart without bringing it down in chaos. Holding a building together was not just about what you took out, but how and when you took it. Crews relied on a kind of engineering chess, planning every move to keep the structure stable as it shrank. Portable screw jacks, simple sturdy devices, became the silent partners in this work. Workers placed them under beams and joists, adjusting their height by hand to take the weight as supports were cut away. Each jack had to be set exactly right, bearing just enough load to hold up the floor above, but not so much that the beam would crack or the jack itself would buckle. The real skill came in sequencing. No one dropped a whole floor at once. Instead, demolition teams kept a strict rule. The removal of heavy supports never got more than 2 stories ahead of the main body of work. If the brickwork on the 6th floor came down, the steel or timber frame 2 stories below stayed in place until crews above finished clearing the next section. This 2-story lag acted like a safety net, spreading the forces and giving workers time to check for shifting or settling before moving on. Jacks were leapfrogged from one beam to the next, always a step ahead of the cut, never left behind. It was not uncommon to see a dozen or more jacks lined up under a single span, each one checked and rechecked as the building's weight shifted. Foremen called out the order for each cut, signaling when it was safe to lower a jack or move it forward. If a beam creaked or a floor sagged more than expected, the sequence paused. Sometimes a jack would need to be cranked up mid-process, taking on extra load until the rest of the supports caught up. Every decision was about control. The aim was to weaken the building in a way that was predictable, never sudden. By planning the sequence, spacing out the removal, and using jacks to manage deflection, crews could guide a structure down in slow motion. The risks were real, but the method gave workers a fighting chance against gravity and kept the demolition on their terms, not the building's. Fire, when used in demolition, demanded a steady hand and nerves of steel. Crews sometimes turned to flame after every other method had run its course, especially where timber supports ran deep inside heavy masonry. The technique was straightforward in theory, but fraught with risk. First, workers cut an ingress at the base of a chimney or wall, clearing out a section just wide enough to expose the main props. These supports were then replaced with thick wooden beams, stacked like bones in a tight lattice. Everything around the site, adjoining roofs, loose debris, even the ground, was soaked with water or shielded by sandbags to keep stray sparks from catching. Once the area was secure, the props themselves became the target. Crews packed the base with kindling and soaked rags, then set the pile alight and stood well back. The fire crept up, eating through each beam in turn, until the weakened stack could no longer hold the weight above. Sometimes the collapse came slowly, a groan, a lean, then a final lurch as the structure gave way exactly where intended. Other times the fire raced ahead, forcing a hasty retreat. The line between control and chaos was razor thin. Fred Dibna, a master of this method, described the precision it required. He said he cut an ingress at the base and burned away the props so the chimney fell, using no explosives. His work became legend in the north of England, where brick chimneys towered over mill towns. Dibna could tilt a stack just 5 degrees before it toppled, guiding thousands of tons of brick to earth with little more than a match and a practiced eye. Fire was never the first choice. Safeguards were strict, and the risk of a runaway blaze always hung in the air. But when the job called for it, the prop burn technique offered a way to bring down stubborn structures without resorting to explosives. If the flames failed to do their work, only then would crews consider black powder, a last resort. When all else had been tried, black powder and dynamite belonged to the most dangerous corner of the demolition trade. Crews reached for explosives only after every other method had failed, when hand tools, fire, and careful weakening could not bring down a stubborn foundation or a thick masonry wall. Even then, the decision was never made lightly. In the late 19th and early 20th centuries, city ordinances and insurance companies kept a close watch on demolition sites. Too many accidents in crowded neighborhoods had taught officials what a misjudged blast could cost. A single mistake could turn a controlled operation into a disaster. In 1904, a foundation blast at the Pabst Building in Milwaukee went wrong, killing 3 workers and sending stone fragments flying into the street. The aftermath was swift. The city council passed an ordinance requiring all demolition blasters to be licensed, limiting the use of dynamite within city limits and mandating detailed plans for every charge. From that point on, explosives became the last resort, reserved for the thickest stone or concrete, and only in the hands of those who held a city license. The preparation for a blast was slow and exacting. Crews drilled holes at carefully measured intervals, packing each with just enough powder to crack the foundation without scattering debris. Heavy timbers and sandbags ringed the site to absorb the shock. Onlookers were kept at a distance, and workers retreated behind barricades before the fuse was lit. The moment of detonation was brief, a muffled thump, a shudder in the ground, then silence as the dust settled. If the charge had been calculated right, the wall would drop inward, leaving the street untouched. If not, the fallout could bring police, lawsuits, or worse. Stories of near misses and close calls spread among demolition crews. Many cities, learning from tragedy, tightened their rules. The use of explosives in demolition became a strictly regulated practice, never routine, always watched. The legacy of those accidents shaped not just the law, but the culture of caution that followed, paving the way for the detailed safety protocols that would define the next era of demolition. Work on a demolition site moved to a strict rhythm, set by the foreman's voice and a silent code of hand signals. The foreman, often marked by old injuries and a reputation for fairness, watched from above or paced the ground with a megaphone in hand. His orders cut through the noise. A nod sent a team to pry loose joists. A whistle signaled beams to be lowered by rope. In the constant clatter of bricks and hammers, words vanished, so crews relied on a language of gestures. A raised fist meant stop. A circling finger told men to haul up. 2 fingers down sent a load to the ground. These signals were drilled until they became instinct, because a single mistake could mean injury or lost profit. The crew was a mix of scaffolders, salvagers, and laborers. Scaffolders built the wooden platforms that let others work above the street, while salvagers eased out ironwork, window frames, and copper pipes, careful not to damage anything valuable. Laborers cleared debris and kept carts moving. Each man knew his place, and the chain of command was clear. The foreman's word settled arguments and set the pace, but the real motivator was pay. Payroll ledgers from jobs like the Crystal Palace dismantling show foremen earning up to £2 a week, more than double a laborer's wage. Bonus clauses promised a share of salvage profits if the job finished quickly and safely. That promise kept the teams sharp. Timing was everything. A missed signal or a dropped load could halt the operation or put lives at risk. Routines mattered as much as orders. Each morning began with roll call and a rundown of targets. The foreman assigned teams, roofers above, salvagers on the main floors, pullers at the chutes. Hierarchy kept the site from chaos. New hires learned fast or ended up with the worst jobs. Veterans earned the right to choose their spots, sometimes trading dangerous tasks for a bigger share of the bonus. Disputes flared when salvage was at stake. In New York's tenement clearances, crews argued over iron columns and copper wire. The foreman's ruling was final. Payroll records and court cases from the early 1900s show strict enforcement, wages docked for theft, bonuses paid for honesty and speed. Demolition was a test of trust. The foreman's authority, fair pay, and the choreography of signals turned chaos into order. Without that discipline, even a simple job could become dangerous or waste the materials that made demolition worthwhile. Wooden scaffolding rose alongside the building as soon as the first roof timbers came off. These temporary structures, built by teams of specialist scaffolders, formed the backbone of every safe demolition. Planks were braced with diagonal timbers and lashed tight with rope, creating walkways and platforms at every level. Scaffolders worked ahead of the main crew, planning each tier to match the pace of dismantling above. Their work demanded both speed and precision. A platform out of level could tip a load or send a worker tumbling. Each upright and brace was checked by eye, then hammered home with a mallet, the sound echoing through empty floors. For the heaviest jobs, scaffolders and riggers joined forces. When a beam or iron column needed lowering, they set up a gin pole, a tripod of stout timbers anchored in the rubble below. At the top, a pulley and block gave the crew mechanical advantage, turning muscle power into control. Riggers ran thick hemp ropes through the block, tying off with knots they could trust. 2 or 3 men at the base hauled in rhythm, easing a beam down inch by inch. The gin pole's tripod legs braced against the shifting weight, flexing but never buckling. With each load, the pole was reset, inching closer to the ground as the building shrank. On city streets, canopies stretched out from the scaffold to shield pedestrians from falling debris. These sidewalk protections, built from thick planks and heavy canvas, were required by city ordinances in places like New York by the early 1900s. Underneath, life went on. Shopkeepers opened their doors, carts rolled by, and children played, safe from the work above. Workers trusted the canopies too. When bricks or plaster slipped from a chute, the impact was muffled and the street below stayed clear. Riggers kept a close watch on every moving load. Signals were given by whistle or a wave of the hand. If a rope squeaked or a pulley jammed, work stopped until the problem was fixed. Safety depended on the rigging holding firm and the crew moving as one. A single frayed rope or loose knot could undo hours of careful planning. Diagrams from the era show elaborate bracing, crossed timbers, angled struts, and extra lashings, ensuring the scaffold stood strong even as the building disappeared around it. The work of scaffolders and riggers was both visible and invisible. Their platforms carried the crews, their rigging lowered the bones of the building, and their canopies sheltered the street. Every safe descent of a heavy beam or safe passage of a worker owed something to their skill. As demolition pressed on, these mechanical solutions brought order to the chaos, making it possible to dismantle even the tallest structures without a single swing of a wrecking ball. Demolition work before the age of hard hats and safety harnesses demanded a different kind of vigilance. Crews relied on skill, experience, and a set of improvised safeguards to keep disaster at bay. Ropes played a crucial role, not just for lowering beams and debris, but for the workers themselves. On upper floors, workers often tied thick hemp lines around their waists or looped them through belt hooks, anchoring the other end to a solid timber or scaffold post. These makeshift harnesses offered a last line of defense against a slip or a crumbling edge. It was not foolproof. Ropes frayed, knots failed, and sometimes the anchor gave way, but for many, it was better than nothing at all. The absence of modern protective gear meant every step carried risk. Boots gripped on dusty planks, hands wrapped in rags to ward off splinters and sharp edges. Helmets were rare and eye protection almost unheard of. Instead, safety depended on the judgment of the foreman and the caution of the crew. Veteran workers learned to read the building's mood, a sudden creak, a shifting shadow, the faint vibration of a loose beam. These signs were warnings, and the best crews knew when to pause, shore up a weak spot, or call for extra hands. Accidents still happened, and the fatality rates bear it out. In the 1890s and the early 1900s, fatality rates on demolition sites were far higher than today. Newspaper clippings from New York and Chicago tell of men falling from scaffolds, crushed under collapsing walls, or struck by falling bricks. Some jobs, like the Gillinder Building teardown in 1910, recorded injuries almost weekly, with at least one fatality among the 350 men on site. Insurance records and city reports from the era show that falls accounted for nearly half of all demolition deaths. A grim reminder of the limits of rope and experience alone. Still, crews adapted. On especially dangerous jobs, teams doubled up on lines or rigged safety nets from canvas and rope beneath the work area. Some foremen insisted on daily inspections of every knot and anchor. If a man was seen working without a harness, he risked a docked wage or a quick dismissal. These measures could not erase the dangers, but they did set a baseline of care, one built not on regulation, but on the hard lessons of the trade. For every successful job, there were stories of close calls and narrow escapes. A missed step on a rain-slicked beam, a rope that held just long enough, a comrade's shout that stopped a man from walking into empty space. The human cost of demolition was real, and every worker knew it. Safety was not a set of rules or equipment. It was a culture passed down from one crew to the next, written in scars and shared warnings. These field-bred protocols formed the backbone of demolition before the wrecking ball, shaping the lives and sometimes the fates of the men who took buildings down by hand. Every piece recovered from a demolition site had a price attached. From the first swing of a hammer, crews worked with one eye on the salvage pile and the other on the market. A seasoned yard proprietor could walk a gutted building and estimate the value down to the penny: bricks, beams, iron pipes, copper wiring, even slate tiles. In the late 19th and early 20th centuries, salvage was not a side benefit. It was the main event. Bricks fetched a half-penny each if cleaned, more if the old mortar chipped away easily. Timber beams, especially old-growth pine or oak, brought in steady buyers, builders, carpenters, even shipwrights looking for straight, seasoned lumber. Iron columns and pipes went to foundries, where they were melted down and cast into new shapes. Copper and brass fixtures stripped from walls and ceilings were the day's real prize, sometimes outpacing the wages of an entire crew. Recovery rates on a good job could hit 70%, even 90%. That meant nearly every brick, beam, and board found a second life. In New York's tenement clearances, for example, classified ads offered clean Bowery bricks by the wagon load, and local builders snapped them up to save on new materials. A single 6-story building could yield over 300,000 bricks, each one cleaned by hand and stacked for resale. Payroll ledgers from the Crystal Palace dismantling list thousands of iron columns and glass panes, inventoried, labeled, and shipped out for reassembly, with most of the original structure reused at Sydenham. For the crew, the incentive was clear. The more they salvaged, the more everyone earned. Bonus pay was tied directly to the value of reclaimed materials, not just the speed of the job. Economics shaped every decision. Rushing meant broken bricks and splintered beams, lost profit. Careful work paid off both for the crew and the proprietor. Salvage yards grew into thriving businesses, some family-run for generations. In the heyday of manual demolition, a well-run operation turned waste into wealth, feeding a local economy where yesterday's building became tomorrow's foundation. The patience required was not just about safety or pride, it was about squeezing every last bit of value from the bones of the past. Rain, snow, and freezing winds could bring a demolition job to a halt for days or even weeks. Contracts spelled out these risks in black and white, with clauses for weather delays and penalties for missed deadlines. A demolition foreman checked the sky as often as the work site, knowing a sudden storm might mean lost time and lost wages. In New York or Chicago, winter ice made scaffolds treacherous and ropes stiff, while summer heat slowed crews to a crawl. Some jobs, like the dismantling of the Crystal Palace, stretched over 2 years, not just because of the building's size, but because rain and fog could stop glass removal or make ironwork too slippery to handle. Contracts set out milestones: roof off by June, ground cleared by November. But the fine print always included force majeure, covering everything from hurricanes to strikes. When a job ran behind, the clock ticked louder. Daily penalties, sometimes as high as £20 in 19th century London or $500 on big American teardowns, loomed over every delay. On the other hand, finishing early brought a bonus, money split between the proprietor and the crew, a rare reward in a trade known for its dangers. Payroll ledgers from the Gelände building demolition in 1910 show a $500 bonus paid for beating a 45-day schedule, with penalties if the crew ran over. Foremen kept meticulous logs, tracking every lost day and every hour made up. If a thunderstorm stopped work at noon, it went in the book. If a shipment of rope arrived late, the tally changed. Sometimes a clever crew could make up for lost time by adding a night shift or splitting into smaller teams to work on separate floors. But there were limits. A run of bad weather could wipe out any hope of a bonus, and even the best crew could not fight a blizzard or a city's fire marshal shutting down the site. Every contract told a story of patience and pressure. The men on the scaffold knew that a single rainy week could erase their share of the bonus, while a lucky stretch of clear days might bring a windfall. Demolition was as much about watching the calendar as wielding the sledgehammer, and every successful job balanced the unpredictable pace of nature with the hard lines of a legal agreement. Dismantling the Crystal Palace became a feat of precision and scale. After the Great Exhibition closed in 1851, Joseph Paxton's glass and iron masterpiece was not demolished, but meticulously taken apart. More than 7,000 workers spent 2 years cataloging every piece, including more than 3,000 iron columns and nearly 500,000 panes of glass. Each piece was tagged, inventoried, and shipped by rail to Sydenham Hill. Payroll ledgers reveal foremen earning double the laborer's wage, with glaziers and ironworkers paid premiums for their skill. Freight records tracked every load, and the catalogs read like blueprints, mapping out the reassembly of a landmark. The palace's structure was reborn, its components traveling miles to stand again in a new form. In New York City, the rhythm of salvage echoed through crowded tenement blocks. Crews, mostly immigrants, stripped buildings in neighborhoods where space was tight and every brick mattered. In the early 1900s, Bowery Classifieds advertised clean, hand-stripped bricks by the wagon load. A single 6-story tenement could yield over 300,000 bricks, each chipped free of mortar, stacked, and hauled to new construction just blocks away. Salvage yards bustled, and payroll records show fierce disputes over the spoils, including iron columns, copper pipes, and door frames. Some crews pooled profits, others fought over every load. The foreman's authority and the team's speed decided who came out ahead. Here, salvage was a street-level economy, shaped by hustle and negotiation. In rural New England and the South, the story unfolded in timber and stone. Contractors dismantled barns and mills built with massive pegged beams, working slowly to preserve every length of longleaf pine and oak. Teams unpegged frames by hand, lowering beams with ropes and pulleys. Only when a foundation refused to yield did black powder come out, and only after every salvageable timber was cleared. Freight records from 1915 trace beams from a Georgia mill traveling over 200 miles to a Florida hotel, while some timber moved as far as 500 miles. The value was in the wood itself. A single barn's beams could support a new structure far from their original home. Across these cases, catalogs, ads, and freight manifests reveal a world where salvage was methodical, profitable, and far-reaching. Today, as cities race to erase and rebuild, demolition is measured in hours, not seasons, and salvage often loses to landfill. Construction waste now accounts for over 1/3 of global landfill volume, so the lessons of patient, resourceful dismantling matter more than ever. The craft that once transformed ruins into new beginnings still holds a blueprint for sustainable futures if we choose to look back before we tear down. What would you save from tomorrow's rubble?